why are companies using traditional chatbots still stuck at like a 65% first contact resolution rate, while the ones using new multi-agent systems are hitting 90% and saving up to 3 million euros a year?
Yeah, that's a multi-million euro question right now.
Yeah.
And it really comes down to a fundamental architectural shift.
Right.
I mean, the era of the isolated experimental chatbot, the ones that just fetch and summarize text, that era is officially over. We are firmly in the age of autonomous problem solving.
Which brings us to the fascinating stack of research you brought in this week, especially that incredibly detailed briefing from EtherLink.
Yeah, the Dutch AI consulting firm.
Exactly.
Yeah.
And if you are a European business leader or a CTO evaluating your AI stack right now, this is the transition you have to pay attention to because, the year is 2026 and we've moved from these single frustrating bots to highly orchestrated ecosystems.
It's a massive shift.
So our mission for today's deep dive is to unpack exactly how these multi-agent systems work under the hood, why they're the absolute key to surviving the new EU AI Act, and how organizations are building what they call AI factories.
And the timing on this is critical, right? Because it's no longer about testing if a large language model can draft a polite customer service email.
Oh yeah, we're way past that.
We are. Now it's about whether a synchronized team of AI agents can actually execute complex back-end operations securely, without human intervention, and crucially, without breaking local laws.
To really understand that massive jump in ROI, from 65% to 90% resolution, we have to look at the leap from a system that just fetches answers to one that actually takes action.
Right.
I mean, we know the baseline. A traditional chatbot is purely reactive. You ask a question, the bot scans a vector database, grabs the text snippet, and spits it back. It's basically a search engine wrapped in a chat interface.
Yeah, and that reactive model hits a ceiling incredibly fast. Agentic AI, on the other hand, is proactive.
Meaning it doesn't just sit there waiting for a prompt.
Exactly. Maybe the user initiates it, or maybe the system just detects an anomaly in the background. The agent evaluates the context, makes a decision, and then actually executes an action via an API.
Like booking an appointment or issuing a refund?
Right, and then it reports the outcome. It's an entirely autonomous loop.
It's kind of like the difference between a basic library catalog that just tells you a gardening book is on aisle 4 versus an entire staff of concierges.
Oh, I like that analogy.
Right. One concierge finds the book, another reads and summarizes the tomato growing techniques for you, and a third proactively orders you a coffee because they noticed your flight was delayed.
That coordinated effort is the exact hallmark of a multi-agent system. And the EtherLink briefing gives a great practical scenario about a delayed logistics shipment to illustrate this.
Oh yeah, walk us through that one.
So in a traditional setup, the customer complains and the bot replies with a generic, your shipment is delayed message.
Which is incredibly frustrating.
Very. And then human agents have to scramble across like 3 different legacy systems to actually fix the routing.
A process that usually takes days and makes the customer repeat their order number every time they get transferred.
Exactly. But in an orchestrated multi-agent workflow, the mechanics change entirely. The customer reports the delay. Agent A, acting as the triage agent, runs sentiment analysis and assesses the logistical urgency.
So it immediately knows what kind of problem it is.
Right. It spots that there is a genuine routing issue and then passes that specific context securely to Agent B, the operations agent.
And Agent B is the one doing the heavy lifting.
Yeah. It independently queries the warehouse APIs, finds an alternative route, and rebooks the item. Then Agent C, the customer engagement agent, steps in to proactively offer compensation and update the customer.
And all of this happens in, what, milliseconds?
Literally milliseconds. And because they share a unified memory state, the context is never lost.
Which brings us to the staggering economic reality of this efficiency. I was looking at the 2025 Gartner benchmark data included in the sources.
The cost per interaction numbers.
Yeah. These orchestrated systems cost between 15 and 30 cents per interaction. Compare that to 3 to 5 euros for a human agent.
A massive difference.
And they're maintaining a 78 to 85% customer satisfaction rate, which is completely comparable to human-led interactions for these kinds of procedural issues.
Well, autonomy is a fascinating computer science problem, but the CTOs and business leaders listening to this are definitely doing the mental math on those unit economics.
Absolutely.
When you move from concept to actual financial impact, you see why this architecture is taking over. The briefing details a European financial services firm that implemented an AetherBot-based system across support, fraud, and back-office ops.
Right. Before deployment, this firm was dealing with 3,200 monthly inbound inquiries. They had that standard 65% resolution rate and a brutal 48-hour average response time.
But just 6 months post-deployment, the transformation was wild. The number of inquiries that actually needed to reach a human dropped by 34% down to 2,100.
And that drop comes directly from the triage agent using dynamic confidence thresholds, right?
Exactly. When an inquiry comes in, the agent calculates a confidence score for autonomous resolution. If it's above 85%, the agents handle it end-to-end.
And if it falls below that,
Or if it detects high emotional distress, it instantly routes the ticket to a human, alongside a complete diagnostic summary. That is how their average response time plummeted from 48 hours to just 4 hours.
because the humans aren't doing the tedious data gathering anymore. They're only doing complex problem solving.
Which is why they saved 580,000 euros annually. And it wasn't just, headcount reduction.
Right, the breakdown is fascinating. They saved 340,000 euros by eliminating the swivel chair problem, where agents constantly switch between legacy systems.
But they also saved 180,000 euros purely from better fraud prevention. The multi-agent system spots these micro-anomalies across channels in real time that a human reviewer would just miss.
Plus another 60,000 from general operational API efficiency.
Which brings us to the AI factory concept. This firm didn't just buy a chatbot. They built an infrastructure capable of churning out these autonomous workflows at scale.
Okay, wait, let me push back on this financial model for a second.
Sure.
Because earlier in the source materials, they cite a 2024 Deloitte analysis on the cost economics of scale. And it notes that building the first agent, that initial single workflow, costs between 400,000 and 600,000 euros.
With a 2 to 3 year payback period, yeah.
Right. So if I'm a CTO, dropping up to 600 grand on a single workflow sounds like a massive barrier to entry. Why shouldn't they just buy a basic off-the-shelf bot for 50 grand and call it a day?
That is the exact trap so many organizations fell into during the initial generative AI boom. You buy a cheap, isolated point solution, but then you realize it needs to talk to your CRM.
So you have to build a custom integration.
Right. Then you want it to trigger a refund in your payment gateway. That's another custom integration. You end up with this tangled, fragile web of digital duct tape that breaks every time an API updates.
Which sounds like a maintenance nightmare.
It is. The AI factory approach flips that premise entirely. Yes, the initial 600,000 euro investment is steep, but you aren't just building one agent. You're building the centralized factory floor.
So you're investing in the orchestration platform itself, a unified governance system, a modular agent library, shared data infrastructure.
Exactly. And this is where tools like AetherLink come into play, allowing development teams to centralize their builds. Look at Deloitte's data for what happens after that initial investment. By the time you build your fifth agent on that shared platform, the incremental cost drops to between 80,000 and 120,000 euros.
Oh, wow.
And by your 10th agent, the incremental cost is down to just 30,000 to 50,000 euros. At that point, the ROI breaks even the moment you deploy it.
Because business teams are just pulling pre-built compliant agent modules off the shelf and snapping them together in days instead of months.
Precisely. The AI factory is essentially a centralized assembly line for autonomous workflows.
But if enterprises are scaling up to dozens of these autonomous agents, all running around making decisions and firing off APIs, how do they prevent these bots from stepping on each other's toes?
Or duplicating work.
Right. Or worse, making conflicting promises to a customer.
That is the ultimate orchestration challenge. If you have dozens of autonomous models operating simultaneously, you need a rigid architectural standard to prevent chaos. And the industry solution is known as the three-layer model.
So layer one is perception and input. This acts as the multimodal context manager.
Right.
Say a customer calls the support line about a billing error, and then 2 minutes later sends an email with a screenshot of that same error. Layer one ensures these aren't treated as two separate issues.
Mechanically, it does this using multimodal embeddings. It maps the visual data of the screenshot and the audio intent of the phone call into a shared mathematical space, tagging both to the active session ID in real time.
So it fuses them into a single context, preventing two different downstream agents from trying to solve the exact same problem twice.
Exactly, which feeds directly into layer two, orchestration and coordination. This is the central brain.
Using frameworks like LangChain or AutoGen, right?
Yeah. They act as the central router, utilizing graph-based logic to look at the fused context from layer one and decide which specialized agents need to be activated. Layer 2 also maintains the shared state so every agent knows exactly what the others are doing.
Which brings us to layer 3, execution and governance. This is where the individual agents, like your triage agent or transaction agent, actually perform the work. And crucially, they operate in strictly sandboxed environments,
Right.
meaning containerized execution where an agent only has permissions for its specific API. Its outputs are parsed into strict JSON schemas, and if it tries to execute a command outside that schema, the sandbox just rejects it.
Precisely. Every single decision is logged with its underlying reasoning. And to manage the chaos of multiple agents acting at once, the system uses a concurrency control mechanism called distributed locking.
I love the restaurant kitchen analogy for this.
Oh, it's perfect.
Yeah, so the orchestrator, layer 2, is the head chef standing at the pass, calling out orders. Layer 3 contains your line cooks. But you can't have two line cooks trying to salt the exact same pot of soup at the same time.
No, that would ruin the soup.
Exactly. Distributed locking solves this. If an agent queries the database to, say, rebook a flight, it places a temporary lock on that specific customer record. All the other agents see the lock and don't intervene.
It ensures that routing is deterministic following strict, predictable rules rather than probabilistically guessing who should do what.
Okay, but if the orchestrator is deciding who does what, how do we stop an agent from hallucinating? What prevents a customer service bot from confidently telling a user, yes, your $1 million refund is approved, when company policy absolutely does not allow that?
Hallucinations are mitigated through dedicated fact-checking agents. In an orchestrated architecture, customer-facing agents aren't just relying on their parametric training data, they're connected to live data sources.
Like the actual CRM and the live inventory?
Right, the real payment systems. Before a response is ever surfaced to a customer, a separate evaluator agent cross-references the generated output against a verified SQL database of company policies. If it conflicts, it's blocked and regenerated.
It's like having a sous chef taste every dish and check it against the recipe before it leaves the kitchen. And a massive shift noted in the sources is that this entire three-layer process is now happening natively across multiple modalities. 2026 is highlighted as the major inflection point for multimodal voice systems.
Yeah, for years, voice AI was considered this premium high-latency feature. You know, the old cascaded systems had to run speech to text, feed that to an LLM, generate a text response, and then run text-to-speech. It was computationally expensive and painfully slow.
But models like Grok GPT-4o and Claude 3.5 process audio tokens directly end-to-end. By removing those middle translation steps, voice has reached cost parity with text.
Which fundamentally changes customer service.
Right.
I mean, McKinsey reports 67% of customers actually prefer voice for complex issues.
It makes sense. If you have a highly nuanced problem with your bank, you don't want to type a novel on your phone. You want to just explain it naturally.
And these new native voice agents capture that audio intent, run biometric voice verification instantly, and coordinate with the back-end orchestration layers exactly like a text agent would.
But we have to address the reality of deploying this technology. You can have the most efficient, cost-effective system in the world, but if it operates in Europe and fails a regulatory audit,
You will be shut down and fined heavily. For European businesses in 2026, the ultimate test is the EU AI Act.
right, so we have this incredibly efficient system firing off autonomous transactions. But the moment an AI touches a user's finances or makes a customer service decision, it triggers a massive regulatory tripwire. Article 6 specifically classifies these systems as high risk. How does orchestration actually prevent a company from getting sued?
Well, if a company deploys a fragmented web of isolated agents across different departments, they are creating a compliance nightmare. When auditors arrive, it takes months of retrospective remediation to figure out how those siloed models made decisions.
But orchestrated systems fix that.
Yes, they provide absolute auditability. Because of that three-layer model, the orchestration logs show the exact deterministic decision chain. You can prove to an auditor why an agent took an action, what specific data informed it, and which business rule applied.
Let me play devil's advocate here, though, because I hear the words autonomous AI and financial decisions in the same sentence, and my immediate thought is a GDPR liability disaster. If we have bots processing refunds and accessing account histories, how can we possibly trust a machine not to accidentally bypass local laws or expose private data?
That valid concern is exactly why orchestration is mandatory. To handle that liability, the architecture relies on a highly specialized compliance agent. It acts as a hard gatekeeper within the execution layer. No action can be executed without passing through it first.
So if the transaction agent wants to process a refund, The request hits the compliance agent, which checks it against financial directives like PSD2 for payment security and a MiFID II for transparency.
Correct. The compliance agent ensures the system isn't bypassing local laws. If it flags a risk, say, a transaction requires strong customer authentication under PSD2, it intercepts the process. It stops the back-end execution, triggers the required authentication protocol with the user, and logs the entire intervention for the audit trail.
It is the bouncer at the door of your API.
Exactly.
The AetherLink briefing also highlights their consultancy arm, Ethermind, which helps companies build governance dashboards on top of these systems. Stakeholders get real-time visibility into agent activity.
Which is vital. They monitor for bias to ensure the models aren't discriminating against certain customer segments, and they track compliance status continuously.
Because under the EU AI Act, you must prove human oversight. These dashboards provide clear escalation paths, ensuring humans are reviewing edge cases before there's any customer impact.
And the data speaks for itself. These aligned orchestrated systems show a 94% compliance audit pass rate, compared to just 67% for fragmented point solutions. Compliance by design is exponentially cheaper than compliance after deployment.
We have covered a massive amount of ground today, from the technical evolution of proactive multi-agent ecosystems to the raw unit economics of the AI factory and the intense regulatory reality of operating in Europe in 2026. Looking at all these sources, what is your number one takeaway?
My top takeaway is a fundamental shift in how organizations need to view regulation. Compliance is no longer just legal cover. It's not a checkbox you hand to your legal team at the end of a software build.
Right.
Compliance by design, having that hard gatekeeper and deterministic orchestration layer, that is the foundational architecture that enables these multi-agent systems to scale safely in the first place. Without the governance layer, you simply cannot build the AI factory. What stands out to you?
For me, it is the realization that voice AI has transitioned from a premium novelty to the new omnichannel standard. Achieving cost parity by processing audio tokens natively fundamentally changes the user experience.
It really does.
The idea that a customer can naturally speak their complex problem, and the system instantly translates that audio intent, orchestrates 5 different back-end API calls, checks it against European financial law, and resolves the issue in 3 minutes. It completely redefines enterprise efficiency.
It does. And I want to leave you with a final thought to mull over regarding that efficiency. The benchmark data clearly shows that agentic AI is not meant to replace human customer service teams entirely. It excels at high-volume procedural tasks, acting essentially as robotic process automation on steroids.
Effectively removing the robotic work from the human workers.
Yeah. Exactly. But if we shift all of our routine procedural tasks to an AI factory, what does the future human factory look like? If machines handle every standard transaction, your human workforce will be left exclusively with the complex, emotionally demanding, high-empathy edge cases. How do you need to retrain your human workforce today so they can specialize entirely in empathy tomorrow?
That is a fascinating question and a critical challenge for any leader building these systems, the human factory. For more AI insights, visit etherlink.ai.